6800, this type of ground truthing sensors that will give us some ground truthing observations. So given these sensors, these instruments, we can actually quantify mostly on the plant phenotyping focused on water stress quantification. And based on that, we can actually manage water better. So this is my lab. A few students are working on different programs. I guess Dr. Bullock would like me to share more on the on-farm research, right? I will focus more on that part. So one of the research programs is this on-farm water management. So unique in this environment here, water is limited. So the question is how we can allocate water, the limited water in that particular field, so that we can actually improve the bottom line of the whole field instead of like a spread water everywhere. But the question is, okay, how do we actually allocate water? So really allocate water to the right place at the right time. It's actually pretty challenging. So in this field here, for example, we have to actually work with farmers to answer the question. So the farmers, they will actually have a prescription map. We will help them answer, okay, where you should actually allocate more or less water, but we don't know either. So based on that, we actually create a few zones, and then we can have the low, medium, high, different irrigation rates across the field, so that we can actually do the analysis. For example, Dr. Bullock's on the response curve thing. We actually have to collect data to actually quantify that. So this irrigation system actually allows us to actually apply the right amount. When I say right amount, it's still like a tentative. And this technology actually will go something like this. You increase or decrease your speed to actually apply a lower or higher amount of water at a specific location. Now, there's another technology, actually, it's based on the zone. Okay, I will share with you a moment why that one is not working in here. Harvest what?
That circle, right?
Oh, so
Monitor in a certain area long enough to get a good read on yield.
yeah. So the question is, how do you actually harvest? Do you have enough area to actually quantify the yield in a specific plot area, right? Yeah, so this field is big enough. And each slice is like at least 100 meters long. Okay, when we harvest, the farmer actually drive the harvester this way. Okay, not this way. Okay, so we have continuous data. So one of the challenges actually to work with the right person to get the technology to work with this stuff. Okay, another research is on the drone technology to quantify the water stress conditions. Okay, I guess I won't focus too much on this one, but we do have the technology actually using multispectral and also thermal sensors to actually link this NDVI from the multispectral sensor and the thermal sensor to look at the temperature. So based on this, the combination of these two parameters, we can actually quantify better, okay, where's the low or medium or the high stress conditions for a particular, like a stress or different levels of stress plants. Okay, so this is another on-farm research on nitrogen in a dryland cotton field. Like I mentioned a moment ago, north of Lubbock, we have more irrigated land. And south of Lubbock, we have more dryland cotton. But overall, in this area, we have less and less water. So one question is actually with less water or even dryland, how do we actually manage water in this type of fields? A lot of people think West Texas is flat. But if you go, especially south of Lubbock, the topography changes a lot. You have like a 6 to 10% of slope. That's pretty normal, especially in this type of fields. So this is like a contour here. One of the challenges here, like I remember asked Dr. Bullock, you do the straight lines, like do the experimentation. How about on the curves? So
Some of that, talk about that.
Yes. So this farmer, he has these technologies to apply the right amount of nitrogen or some other inputs in the right place. In the beginning, the one of the challenges is actually how do you actually implement this research. And technically and more right, I think it would be applying like a various ways. So you can have different like combinations of different rays at different topography here. But in the beginning, it's like it's much easier to do this way.
Design experiment, so it goes around the curve like that.
To around the curve, like inside.
Design the plots so that they're going like this. So every one of those strips, you know, might have 20 plots.
Right.
That are semi-circular.
Mm-hmm. Right.
We can do that.
So we can actually do the post-processing on this one, even though, you know, we have the continuous, the same rate within the same strip. But when you do the analysis, we're actually doing this like a different slices in it.
Patternized that so there's variance.
Exactly.
Right.
Yes. Yes.
So it would be better to turn that into a curved checkerboard.
Yes.
Right.
Yeah. 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 I wish I knew this one 6 years ago.
I wish I had data.
Yeah. Okay. We also work with vineyards to quantify the variability of the vines. One of the challenges is like there's a lot of variabilities in the vigor of these vines. The producers actually, they prefer the medium vigor within the field. If you have very weak vigor, that means your yield will be pretty low. The quality is probably bad too. We just got into this one. If you have very vigorous vines and they have a lot of leaves, you could grow like a tree, but without fruits, or the quality will be very bad. So we want to use this technology, the drone technology, actually to quantify the variability of the vines within the field. And then based on that, the producers can actually manage these vines according to the variability. So what we found is that at a low, like a depression area, the water and the nutrients, the water content within the soil and the nutrient level is very high. But it doesn't need to be that high. So the question is how we can actually manage accordingly so that you don't have to have a very high vigor at the low elevation area. Okay, another project is also on-farm study. We just got started this year, supported by USDA and NIFA, and also the Cotton Board. The question to ask here is like within this transitioning environment, is from irrigated to dryland, what would be a sustainable cropping system? How do we actually manage water at different cropping systems? For example, cotton, that's a continuous monoculture. Or you have cotton sorghum, or you have cotton wheat programs. Really, it's like the question, how much water do we need at a field level, or how much water do we need to allocate within the field level? So this research is actually integrating the satellite remote sensing, UAV remote sensing, data collection at the farm level and also within the field level. And we're also actually using some simulation programs to really quantify in the future within a particular, like the change of climate change scenario, what would be the more sustainable cropping system in this type of climate? Yes. Yes.
Sorry, are you monitoring between the rainfall and what the soil is actually able to capture and what you're able to store and hold in your calculations of what you're working on here?
Yeah, in general, we actually have to look at how the rainfall soil, like the water, the use efficiency, or how much effective rainfall is actually on the ground. For example, you have 1 inch. Are you really using that 1 inch of water or not in the soil? Typically, it's not. And a lot of people use like 75% or even lower on that. But when we do this this kind of a simulation, we have to look at, okay, the input for the irrigation and also the rainfall and how much is actually being used. We have to quantify how much water, like the water content in the soil. We have to collect all the data to actually to have the input data to do the simulation.
About 8 years ago, we did a bunch of this work.
Mhm.
Where we drug EC machines around and we got bulk density readings up the pit.
Yes.
And then we did water infiltration rates. And then we put monitors in the ground that were reading every 2 inches. So we knew what the irrigation was doing we knew how much was retained, and then like how much was evaporated.
Okay.
And that's how we were kind of like designing.
Okay, what would be your challenge in there? You to do like every 2 inches across the whole profile vertically?
Yeah, they put straight down, and they stayed in the field.
Uh-huh.
Okay.
Okay. We also have these sensors installed in some fields here. We actually work with a crop consultant in the region. The crop consultant is actually installing those sensors in the field. And we have the algorithms according to some other like companies, they give these prescriptions. And at a particular time, how much water you should apply within the field. It's also a variable rate, like I showed a moment ago, like that.
Yeah.
Yeah.
The monitors or sensors will actually show where it's pulling the water from.
Right.
So it gives you kind of a ballpark idea of what the depth of the root system.
Yeah. Okay. All right. We also work with some breeding companies to do this high throughput plant phenotyping. Like I said a moment ago, how to actually improve the plants. So you have different cultivars or varieties. We want to quantify how we can actually like do the high throughput plant phenotyping to select the right cultivar so that they are actually water stress resistant or tolerant. So these are working with BASF. I won't show too much about that. To highlight a few publications, this is the on-farm research we did for several years. And also I want to share the challenge in here. Okay, this one was conducted in 2017. Okay, you might ask, the question is like, why you don't show like a multiple years of data? First of all, we found out in 2017 is actually a favorable year, climate or weather-wise. We have the right amount of rainfall at the right time. So it was not stressful for the plants in that year. However, we have significant interaction between topography and other environment and irrigation rates. Okay, although the high and the medium, the irrigation levels across the whole field, I mean, between different treatments, there's no significant effect. But the crop yield at different landscape positions, they are significant. So that means there's potential to actually improve the water allocation at different landscape positions. So topography and soil texture have a significant impact on that. All right, so this is a kind of like a study on a site in the same field, and this is related to soil erosion. So we found out the excess amount of calcium on the soil surface actually indicate soil erosion. So if you have very high amount of calcium on the soil surface, that indicate soil erosion. So that if you do not apply too much water at the slopey area, you can actually reduce the amount of erosion. So that's the key message from this study. So this is on-farm study too. We actually applied, we call it like a temperature vegetation index combined with the soil texture information. We can improve the estimation of soil moisture, the surface soil moisture content. This is some kind of a machine learning stuff one of my students was working on for his PhD program. So using a deep learning program, we can actually quantify the sorghum heads. So we look at the number of images needed to have a very good estimation. So of course, the more images you have, the better the precision and accuracy would be. But at about 600 or so, you steadily will increase the accuracy and the precision. Okay, that's the key message there. Another one we worked on is the cotton stand count at the seedling stage. We also use some different types of machine learning technologies to quantify the number of plants. Okay, so we can have more discussion on the challenges on the on-farm studies. In this area, I focus more on the variable rate, like irrigation studies. So this one I mentioned a moment ago, is this is the right, I think, the right technology to really apply the right amount of water at right place. Okay, so this one is really based on a prescription map. So if you give this map like this here, it will apply the right amount in this high irrigated area. In this here, it's actually dry land. We don't apply anything. So this study was actually based on like a 3 different rates, like a 0, 0.5, and a 1 inch per week or so. And then you see this one is across the whole field here. And then this is the farmers, their own prescription map. So we want to analyze what would be the right amount of water across the whole field. Okay. So the challenge here is this technology is still available, but the service is not available anymore. The service is like you have the hardware. So the prescription map is not enabled if you do not have the service in there. It means the company have to enable a code so that you can actually do the right thing in the right field. Yes. Okay. The challenges on the on-farm study. Number 1 is actually to find the right person at the right place with the right technology. For example, we want to do variable rate irrigation. We have to go to like a north of Lubbock to find that right person. The person also have to have some kind of a precision technology so that we can actually give them a prescription map. They can actually implement it. They also have to have some kind of a yield monitor system to collect the right data so we can actually do the analysis. And not like the corn belt where you always have a yield monitor. For the cotton country, you don't have a pre-built like a yield monitor. And now maybe we have the hope now John Deere has some cotton yield monitors we can use. Okay, one of the collaborators we have now, he has the John Deere yield monitor, so we can actually work with him. Another challenge is actually to implement the experiment. And you have to align your own design with the farmers, the producers' needs, and also the setting. You just cannot do everything you want. You have to actually communicate with the producer. Okay, what do you have? What do I want to implement? And we have to be on the same page, and the understanding has to be consistent. Otherwise, later you have troubles. Number 3 could be some data quality control. And we think we have something like that. The farmers, their management, it could be like, I want to do that. You cannot just always do what you wanted. So another one would be the unexpected events. And this one is like a more extreme, something like, okay, well, we think everything is going well. If we don't go to the field, like in 2 weeks, something bad may have already happened. For example, in 1 year of this research here, they actually spread the wrong chemical to kill all the crop within that whole field. We lost 1 year of study. Okay. Another one is the technology consistency. Like I mentioned a moment ago, that technology is really great. Okay. That really allows us to apply the right amount of water at the right place. But they don't support that anymore. So that kind of inconsistency will actually create some troubles or challenges for our technology, for our on-farm research. The reason we have to do the speed control for the variable rate irrigation, because that's actually much cheaper and people can actually afford it. They can actually do something more than the uniform irrigation application they are doing now. Okay, that's my presentation and more of a discussion, something like that. Okay, thank you.